right, you guys, this is going to be a video about transformations of functions. This is page 15 of your packet. You are welcome to do this activity as it was originally intended, which is to be like a discovery activity through Desmos. Just because we don't have tons of time, I thought I would just kind of make a quick video for you on this lesson. This is a review from last year. These are where all your parent functions move. Sometimes they move right, sometimes they move left, sometimes they move up, sometimes they move down, sometimes they flip. You know, there's all different things that happen. So just how we talked on Friday, or not Friday, gosh, the last time we met, was that you need to get in the habit of knowing what these look like. The quadratic function is a parabola. Oh, geez, look at that. Let me try to make that look better. The vertex here is at 0, 0. Ooh, oh my gosh, that looks so terrible. Sorry, you guys, but you know, it's not exactly like that, but that's the general shape. A cubic has that point of inflection at 0, 0. It rises to the right and kind of falls to the left. Absolute value function is a v. Again, we talked about that a little bit. And then a square root function looks like this. So these are all your parent functions. Now, if you plugged in x values, you would see that they make these shapes. It would be a lot more precise than what I just made, but at least you get in the picture. So you need to start remembering what these look like. And then all of these functions move. They move according to the numbers. So if you take a look at 3 here, and you'll notice that I have all of these different functions, but the numbers that are in with the functions are inside the functions. When you have numbers inside, it moves the functions left or right. And I always tell my students they're kind of the opposite of what you think. A -3 actually moves it to the right. A plus moves it to the left. So this is going to take your quadratic function and move it right 3. This one's moving it, your cubic, left 1. Here's a +5 inside, so that's going to move it left 5. A -5 inside the root is moving it right. So one of the transformations is the left and right shift. The numbers are located inside the parentheses or the absolute value or the square root, and they move left or right. Second thing that we need to review is what happens when you have the numbers added or subtracted after the parentheses or the absolute value or the square root. And you're welcome to stop the video and try to make a guess or use your graphing calculator to kind of investigate. But I'm going to tell you right now, just for the purpose of the video, what happens. So when you have the number that occurs after, it moves it up and down. And this is exactly what you think. Down is negative and up is positive. So if you take a look here at this first function, x squared minus 4, the parentheses for this would have been right here. Oh, geez, that looks terrible. Sorry, but you get the point. So this -4 is like after. So this is going to move it down 4. The cubic plus 2 at the end would take this cubic and move it up 2. Absolute value of x plus 5, since the plus 5 is on the backside or outside of the absolute value bars, this goes up 5. Same thing here, the square root, since it's after the root, that's an up or down shift, and since it's positive, it's up. If you take a look at the next example here, we have some combinations. So if you take a look at A, I'm going to try to make this a little bigger. I don't know what this is going to do for the video. All right, if you take a look at A, we have an absolute value, so right away you need to think V. Then I have a number inside, that's the left or the right shift. Since it's a plus, it's the opposite of what you think. It's going to go left 3, and this number after is going to go down 2. So your normal absolute value V starts with the vertex at 0, 0. So it moves the entire graph, but I think we should move the vertex and then kind of just sketch from there. So I'm going to go put my pen at 0, 0. I'm going to move left 3 and down 2. That's where I put my vertex. And then one thing about absolute value, The number in the front represents the slope of the sides. So there's only a 1 there, so that means to get to the next part of the V, you go up 1, out 1, and you keep going and going and going. So down here, I was just supposed to write left 3 and down 2. Oh gosh, my handwriting, I'm so sorry. Now you can do the same thing with all of these. So I'm going to take a look and I'm going to do the cubic here. The number at the end is moving it down 3. The number inside is your left and right shift. If it's a subtraction, it's going right. So again, I'm moving my original point of inflection, which is at 0, 0. I'm going to go right 2 and down 3. And again, from here, you can just do your rough sketch. It doesn't have to be perfect. The only one that it's easy to make perfect is the one that we did on the left. Square root. Number inside moves it left or right. Opposite of what you think. Positive goes left. The number outside moves it up or down. So up 2. So I'm going to take my original, a regular square root kind of looks like this. So my initial point I'm going to move is going to be at 0, 0. So I'm going left 3 and up 2. And then square roots always go to the right. And then here, I'm going to try to move this. Oh, that didn't work. I don't think I can get over there, or at least I don't know how to do that really quickly. So I'm going to just leave that 1 on the end off. One other thing that we should review in this video is the negatives and positives. And that's one of the hardest parts, actually, of these transformations, is remembering how the reflections occur. If the negative symbol is inside, it is reflected over the y-axis. So here's the x-axis, here's the y-axis. My normal square root graph looks like this. If it's reflected over the y-axis, it ends up going backwards like this. Roughly like that. Here, negative x squared plus 3, the negative when it's in the front, it reflects over the x-axis. So this also has an upshift of 3. So normal quadratic looks like this. Reflecting over the x-axis makes it go like this, and then I would shift up 3. I don't know how to move this. I have to figure that out, you guys, so I can't really get to my graph, but here it is. You would go up 3, and then it would be reflected downward. So that's the graph for this one. All right, I want you to stop this video and then go to the next page. I'm going to kind of show you a couple other equations. I'm probably not going to do the whole next page, but I am going to do a couple things. So watch the next video too, please. Thank you.